Salesforce development day 38. So today we will be focusing on the test classes. We will be talking about the test classes. So test classes, why we needed test classes? What is the purpose of test classes? How to create a test classes? Where can I see the test classes coverage? What are the test classes that I need to do? For whom I need to implement the test classes? Everything we are going to see today. So test class is basically as a part of any application development. Let's take a part of, for example, I'm implementing an application. Could be any application. So as part of application development, we will be implementing a business logic. We will be implementing a business logic. Business logic is nothing but I'll be writing a Apex classes. I'll be writing a trigger. I'll be writing a batch class. I'll be implementing a schedule class. I'll be implementing the visual force or lightning aura or LWC, right? So from these UI, we will be calling the Apex from the backend or integration. As part of this application, we will be implementing the different type of a class. We will be implementing it in Salesforce. And the business logic could be in the Apex class. The business logic could be directly in the trigger. The business logic could be directly in the batch class, or it could be directly in the schedule Apex class. Or if it is a visual force page, then visual force page or a lightning or LWC will be calling the Apex classes from the backend based on the need. And REST API, we will be implementing the business logic in the REST API or any API or a web services. Whenever we implement a business logic, whether I have written the logic correct or not, how can we test it? How can we test the logic, whether I have written the correct logic or not? And let's assume that in Salesforce, we have a development org. We have a development org, which is called as a developer sandbox in the real time. This is a development org where the multiple people are working in the development org, like a Jyoti is working on one functionality. Bharati is working on another functionality. Ram is working on another functionality. Like each member, each developer is working on developer sandbox. When they implement a logic in developer sandbox, and this developer sandbox is nothing but it's kind of a playground where the clients does not have access to the developer sandbox. Where client does not have access to the developer sandbox. So this developer sandbox is multiple people are working here. So whenever we implement any business logic, that means I'm writing a logic in the Apex. When I'm writing the logic in the Apex, now can I move directly to the production? Now, once I have done the logic, like once I have implemented the logic, directly I'll push the logic to the production. Production is nothing but it is a login.salesforce.com where client has access to the production. Now, what will happen if I directly push the data from developer sandbox to the directly production sandbox? The first thing is number of issues are more. Number of issues are more. And the product is not stable. The product is not stable. And then it does not have a proper test cases. It does not have proper test cases. So these all are missing. So we never push a data which does not test it or which we have not written any kind of a test classes. Because whenever we push the direct to the production, even Salesforce also executes the test classes whenever it is pushed to the production. So we cannot push directly from the development to production, which should not happen. In between that, we have a few more orgs are there. In between, we have a few more orgs. Like we have developer pro sandbox, which is nothing but a QA sandbox. Now, in development, the developer has to be implemented, developing the code, as well as they have to do the testing, as well as they have to do the unit testing. So developer has to implement the code and they have to do the unit testing. Once the unit testing is completed, that means everything is working perfectly. Then they will push the changes to the QA org. QA org is nothing but it's a developer pro sandbox where the internal testers will be testing it. Where the internal testers will be testing the logic. Now, once this is done, then we have to move the changes to the UAT org, which is nothing but a partial copy, which is nothing but a partial copy. In the partial copy, we will give this org to the business. That means client. This is where the client can log in here, or a business side, BA will be testing it. On the partial copy, BA will be testing it, or client side, business analyst, whatever is there. They can also sometime log in into the partial copy. But partial copy is fully not available to the client. It is just like a where I can test it as a BA can test it here. So developer will not touch anything in the UAT. Then we will move the changes to the, which is called as a full copy. Full copy, that means replica of production, which is also called as a stage org. In few companies, UAT and stage org is same. In few companies, UAT is a different org and stage is a different org. But most of the companies, UAT and staging org both are same. That means it's a partial copy of the production, which is called as a full copy. Now, once it is moved to the full copy, which is nothing but a pre-prod, that means before pushing the production, now I'll be pushing the data to the staging org, where client can come and test it, the functionality in the staging org, because it is exactly same as the production org. Client can come to that particular stage org and they can test all their logic, functionality, application, everything they can test it. If it is perfectly fine, then we will move it to the production. Now, before moving to the production, you have 4 sandboxes. Now, this is a production and these 4 are called as a sandboxes. These 4 are called as a sandboxes. That means these 4 are test.salesforce.com, test.salesforce.com. Now, these sandboxes are like a QA is a sandbox, which is a developer pro sandbox. UAT is a sandbox, which is a partial copy sandbox. Stage is a sandbox, which is a full copy of sandbox. Now you will be moving your changes to the QA org. From the QA org, you will be moving to the UAT. From the UAT, you will be moving to the stage. From the stage, you will be moving to the production. The time when we reach to the production, now here, first time when the developer do the testing of unit testing, they does it and they will move it to the QA org. QA might find it 10 defects or 20 defects, right? QA might find 20 defects. And then from here, once it is fixed, we will be pushing to the UAT. UAT, we might find 10. Whoever the work testing here in the UAT, it might find. So what is happening here? That issues, the defects, whatever the defects are raised by the QA is decreased. The more I go to the here, I might receive only 5 issues. Now, the more I go here, there will be a 0 issues. That means why we have so many sandboxes is these so many sandboxes are different sandboxes. You might not see some issues which are happening in the partial copy. You cannot find it in the developer pro sandbox. The issues which are happening in the full copy, you might not find it in the developer pro or developer sandbox, right? Because full copy and the production copy is both are same. Now, if full copy is perfect, then you can push the changes to the production because these two are same. These two are same. Basically, this full copy is nothing but partial copy or replica of the production. Now, this is how it reduces the number of defects. Reduce the number of defects when I reach the production and project will be stabilized. That means everything is working properly and the data is stored, everything, the flow functionality, whatever the functionality flow is there, it is working perfectly fine. And by the time I reach here, whenever the Salesforce executed something, whenever we deploy the code from this stage, now we deploy the code everywhere. In order to come from development to QA, you do the deployment. You do the deployment. From QA to UAT, you do the deployment. From UAT to stage, you will do the deployment. Similarly, for the production also, we will do the deployment. Now, as we are doing the deployment, we will be implementing the test classes here. But in the real time, test classes are very important when you are pushing to the production. Sometimes we can ignore because it is not mandatory pushing into the sandboxes, but I don't suggest that without test classes, don't push the changes to this, even sandbox also. Even sandbox also don't push the changes without test classes. Few companies says that it is just a sandbox, so why can't we move the changes without test classes? Can we add directly here my code without test classes? So few companies do that, but I would suggest don't do that. Without any test classes, do not push your code even in the sandboxes. Whether it is a sandbox, whether it is a production, do not push your changes. That means do not deploy your code changes to any other org without a test classes. Without these test classes, don't push it. Now, so whenever we are implementing it, that means whenever we are implementing the application feature, we are preparing the different type of a business logic. Like we are writing the Apex classes, trigger, batch classes, schedule classes, VF, web service, these all we are writing it, right? So once the future has been implemented, for example, everybody's focus is on the development. Whenever we are implementing any application feature or any small enhancement, whatever we are working on the story, everybody's focus is on completing the business logic. Completing the business logic first. So once the feature is implemented, once the business logic is implemented, then the it's a developer responsibility that they have to test each piece of the business logic by using the test classes. It's a developer responsibility. Nobody tell you that you have to write a test classes. It's your responsibility. Whenever you are implementing a business logic, you have to write a test classes for that business logic by using the test classes. And we can test the feature by preparing the automated script. Automated script is nothing but test classes. We will be writing some script in the test classes. Using that, we will be testing the Apex classes or the business logic wherever we have written. We will be testing the business logic by implementing the test classes. So that means in Salesforce, and Salesforce has some kind of a restriction from the Salesforce point of view. The restriction is why everybody says that test classes are important is Salesforce itself has a very strict rule saying that don't deploy anything if you are not meeting the minimum 75% of a code quality. That means any code that you are writing it, or you are developing any code, and if you are deploying that code, whenever you are deploying that code, Salesforce suggests you to test your code. Whenever you are deploying it, it has to be tested by the Salesforce. So there will be a test classes or a testing before deploying it. We need to test the coverage. So if your quality, we have to maintain the minimum 75% of a quality code, whether it is a production server or whether it is a sandbox. Now let's assume that why we have to do this, because in server, right now I have a org. Is the only org that is there within the server. Now here I have a server. Now in this server, do I have only one org is there? No, there is not only the one org. There might be 8,000 orgs might be there within the server. Within the server, 8,000 orgs might be there. Now, if they do not do this kind of a check, if they do not do, if the Salesforce does not do the kind of a check, whatever you are writing it might impact the server. Because of your code changes, it might impact the server, and because of your code changes, there are whatever the rest of the org which are available within the server, all of them will get impacted. All of them will get impacted. So within the server, we are not only the one person who is having the org within the server. There are multiple orgs are there within the server. So maybe 8,000, more than 8,000 could be possible that server can maintain it. When server is maintaining the 8,000 org, then it has to, like, that means before deploying the code, it has to test. That means security testing, right? The scanning it will do, whether you have written the proper code or not, right? Is the test classes, whatever you have written the test classes, is it testing the each and every line in the business logic? Everything it is going to check. If the Salesforce feels that it is hitting minimum 75% of the quality code. When we say minimum, 75% of the quality code is nothing but this code is safe to deploy any other org. Now that means it will not impact any other org, or it will not impact the server, right? So it is safe to move my changes from the sandboxes to the production, or sandboxes to the sandbox, right? It is safe to deploy the changes. So that's the reason Salesforce has came up with saying that we need to have a minimum 75%, minimum 75% of the quality of the code. So by using the test classes, we can maintain the code quality. We can maintain the code quality or coverage so that it should not impact on the cloud. It should not impact on the cloud. Now, when we say 75%, right? Now here we have a different person who are implementing the code. Now, is the 75% specific to one person or a specific to one code, or is it a specific to one class? Ideally, it is specific to the entire org. Entire org, it should reach minimum 75%. Whether you write in this org, whatever the developer sandbox is there, in this developer sandbox, let's assume Jyoti has written the 10 classes, Bharati has written the 5 classes, and Ram has written the 10 classes. Overall, it should be 75%. Overall, when I run the test classes, it should give me minimum 75%. If it is giving more than 75%, that means we are safe. Now, it is simple example. When you are studying in the school, and for suppose you have completed your exams, the final exams are completed and the results came. When somebody asks you the result, what you will say, I got the 62% or a 70% or 80% of the pass mark. Is the 80% is a specific to the one semester? No, right? You are saying the overall you received a 72%. Overall, I passed and I got the 72% percentage. So that means you are saying the overall of the all, that means combining all the semester or combining all the subject, everything you are saying. You are not specifying to the specific subject 72%, the other subject 60%. You will not say all of this, right? In single line, you will say that I have got 60% or I got a 72%. That's it. You will not specify the each subject and what is the percentage. You will not do. So overall, there is a calculation will be there, percentage calculation. Based on that, you will be saying that this is the percentage that I have received in my last exam. Similarly, here also 75% minimum, it is expecting the 75% means overall org level. Overall org level, it is expecting the 75%, it is expecting it. Now, whether you are moving to the QA sandbox or UAT or a production, it does not matter. It has to hit it. Sandboxes, Salesforce does not, it is not a very strict, that means very strict because it is just a sandbox. But when you are moving to the production, Salesforce is, it's completely. If you do not have even 75% also, it will reject it. It will say that cannot deploy these changes because the test classes coverage is, the code coverage is less than 75%. Less than 75%. Now, whenever we are moving the code from the sandbox to sandbox, right? Sandbox to sandbox, as I have mentioned, code coverage is not required, but not required in a sense. Salesforce is not that strict, but as a developer, it's our responsibility. If you are moving to the sandbox, also make sure that you have a test classes code coverage is there, because when we go to the production, that time everybody is in a hurry to implement the test classes. So I would suggest do it when we are doing in the sandboxes also. But Salesforce side, sandbox to sandbox, it is not restricted, but the production is, Salesforce is very strict on the production side. So you cannot move any changes if it is not meeting the overall 75%, the code coverage. So that means we need to build the test classes. We need to implement the test classes for each business logic, for each business logic. So test classes should be prepared for the below business logic components. Like if it is a configuration features, if it is a configuration, we don't need to prepare a test classes. Like you have a lightning flows, you have a automation tools, right? You have a validation rules. For any configuration piece, test classes are not required. Only test classes are required for the one where it says that you are writing a code. Some code you are writing it. For that, it is required a test classes. And before moving your code, we have to estimate the organization code. That means you need to check, setup, build, develop, click on a Apex link, and there is something called estimate the organization code coverage. Estimate the organization code coverage. So you need to check this, estimate the organization code coverage before you are moving the changes to the code, before you are moving your changes to the production org. Now let's go to this org. Now, here, go to the setup, click on a setup. Now, when we click on a setup, here, go to the build, or directly what you can do is you can search Apex classes. Apex classes, go here, Apex classes, click on the Apex classes. And then here you have something called estimate organization code coverage. Estimate organization code coverage. So always check this. Now, when you click on it, it is going to show you right now. Now it says that code coverage is 0%. That means we do not have any code coverage right now because we have not implemented any test classes. Your overall code coverage is 0%. To deploy the code to the production, you must have at least 75%. Right now, code coverage is 0%. So we need to always check that what is the overall code coverage we have. What is the overall code coverage we have? Now, let's move on. That is the place where we will be verifying the data. Now we can verify the each business logic That means whatever the Apex class, could be a Apex class or could be a trigger or could be a batch class, could be a lightning auras class, right? So whatever we are implementing it, we can verify each business logic class trigger code coverage by using the below navigation. In the Apex class, you click on any Apex class. If you are going to the trigger, Apex trigger, click on any trigger. Example, community class. This is my Apex class. So when you click on an Apex class, there it will show one field called code coverage. Field called code coverage. Now on the Apex class level, at the overall, here we have a estimate the organization code coverage here. But if you go on the specific one, you can also check by going to the specific one. For example, account data helper is there. Account data helper is there. Now here we have a one field called code coverage. Code coverage. Now this code coverage is number of lines, right? By 0%. Right now it is a 0%. But what is the actual right now we have? How many lines of code it is there? This is 1 line, 2, 3, and 4, right? And these all system.debug, it does not consider. So assume that there are 6 lines are there. 6 lines are there. 6 lines of code is there. For 6 lines, am I covering the code coverage or not? Whatever the commented one is there, the commented one does not consider. The commented one does not consider. Only the one where we have written the Apex class name or whatever the logic we have written, only it will contain that lines of code. Now here it says that 0%. If it is at 20%, it will say 20%. So that means for each trigger or a business logic class, we have to prepare a separate test class. Separate test class. If you have written a 4 classes, now you have written one Apex class, second and third Apex class, and fourth Apex class. So for each one of them, you need to create a separate test classes. So this is a test class 1, this is a test class 2, this is a test class 3, this is a test class 4. So for each Apex class, you need to implement a different test classes. That means separate test class needs to be implemented. Separate test class needs to be implemented. Now let's see here. In case if I wanted to view the code coverage, in developer console. So far where we have seen in the Salesforce. Now this is one place where I can see the code coverage, and second place is by clicking on the Apex class where we have a estimate your organization code, right? This is in the UI level. In case if I wanted to check in the developer console, open the developer console. At the bottom of the developer console, there is a one tab is called tests. So there you will have a right side, which is called as a overall code coverage. You will be able to see like this overall code coverage. So when you click on this tests tab, you will see view the code coverage you will be able to view the code coverage for all the Apex classes triggers at one place. So this is the place where you can see each class, what is the lines that is written in this class and how much percentage it is covered. Now let me show you that. Let's go to the developer console. Now in the developer console, let's open. Now you have a bottom, there is a one thing called tests. Like we have a different tabs are there, logs, right? Query editor, we have seen test. When you click on a test, this one overall code coverage. Here you can see the overall code coverage for the Apex classes, triggers, batch classes, schedulable, whatever the classes you have, for everything you can see. And this is the percentage, how much percentage is there. Overall, it says 0%. How many lines of code that we have written. So in this class, calculate total revenue. We have written 13 lines. And here, database class, 28 lines we have written. DML helper, 51 lines we have written. And then messaging helper, we have written 82 lines. So for those lines, did we implement a test class to cover those lines? To cover those lines is everything I can see here overall in the developer console. Overall in the developer console. Now we got a clarity that what is the test classes, where can I see the code coverage, how can we see the code coverage, right? And how do I know that how many lines of the in Apex class, how many lines are there, how many lines do I need to cover in the test classes? We have seen. Now, it's time to create a test class. Whenever we are creating a test class, we have to follow some steps. We have to follow some steps. Example or a syntax, right? So we have to, example, I have written a class. The class is, I have used here public class name. And within the class, I have written the business logic. This is my class. My class is public class name. And I have written some logic, business logic I have written. For this class, if I have to implement a test class, if this class, I need to implement a test class. If I want to implement a test classes are written similar to the Apex classes. Test classes written similar to the Apex classes. That means we'll have an access modifier class name, right? So I can use here access modifier for the test classes, either public or a private. You will not be writing the global in the test classes. Test classes will have only public or private. You cannot use the global here. Now access modifier class name, which is nothing but a private class name. Within that, I'll be implementing a test class for the business logic. Now this is similar to the what we have a class, but how can I differentiate? This is a test class, this is a business logic class. Basically, on top of this, whatever the access modifier is there, on top of it, we have a something called annotation is called @is_test. @is_test. Whenever we use @is_test before the access modifier, that means this class is a test class. This class is a test class. So even system will also understand whenever we write an annotation here, @is_test before the access modifier, that means this class gets converted to the test classes. Now it will be preferred as a test classes. It is not preferred as a normal business logic classes. Now, this is the first thing. And second thing is whenever I'm creating the class name, especially whenever I am specifying the class name here, right? So upon preparing the test classes, we have to follow the naming convention for test classes. That means if my business logic class name is a account helper, then my test class name is account helper test. It should be always same as your business logic. What are the business logic is there? That the same logic is here. Now here, whatever your business logic class name is there, it will take the same class name. At the end, it will be added the test. At the end, it will be added the test. If it is a community helper, then your test class name is community helper test. If it is a account handler, your business logic is account handler, then your test class name is account handler test. Now, in few companies or few teams follow the ending of the test. In few teams, what they does is starting with the test underscore account helper. And few companies does is account helper underscore test. And few other members test account helper, right? It's up to the team how they wanted to maintain. But what we have to do is whatever the business logic is there, The testing class name should be included the business logic. Either before or at the end, you need to add a test. Either at the before or a end, you need to add a test. And after or in between, we need to always have a business logic name. This is the naming convention for the test classes. Naming convention for the test classes. Now, we know how to create a naming convention for the test classes and how it is going to be differentiated when we write a Apex class, and what is the annotation that I need to give for that class so that it will be converted as a test class. So we know those steps, just now we have seen. Now let's see the step-by-step how to implement a test class. Now the step 1, test class should be always prefixed with the annotation that we have just seen, which is called as a @istest, which is indicates that it is a test class. That means syntax is you need to first write the @istest, then access modifier class name, and then you need to write a test classes, test code for the test, testing code for the business logic. Now this is the step 1. This is the step 1. Example for the step 1 is now @istest, private class account helper. And then within that, you will be writing the testing code for the business logic. Similarly, other example is @istest, private class auto lead convert triggered test. What are the actual business class name is there? Take exactly the same business class name, and then you will have to enter the test. And in between that, you will be writing the testing code for the business logic. Testing code for the business logic. That is a step 1. Step 2 is you need to prepare the test method. You need to prepare the test method. That means you will inside the test class. Inside the test class. Now, test class is nothing but this is the test class. @istest, private class account helper test. Within the test class, you will be writing a method which says the test method, That means you need to prepare a test method inside the test class, which will invoke automatically upon testing the business logic. Whenever you are testing the business logic, automatically that gets invoked. That means while implementing the test method, we have a certain rules. Rules are test method should be always static method. Test method should be always static method. And test method does not return any value. Usually in the test classes, test method does not return any value. There is no return type. It will always has a void. And the test method should be always defined by using keyword test method. Test method always defined by using the keyword called test method. And we can call invoke the normal business logic. What are the business logic is implemented? We can invoke it from the test method. So in the test method, the first thing is that it is always static. There is no return type. It has to be always void. And you need to specify the keyword called as a test method. While declaring the test method, you need to use the keyword called test method. And then finally, you can invoke the business logic from the test method. So syntax is static test method void. I'm using the keyword called test method. You cannot use any other keyword here. It has to be static test method, void method name, and within that you will be writing the testing code. Example, let's suppose I'm implementing the test class @istest, private class account helper test. Within that, I have a method which is called as a static test method void test account logic. Now remember here, Now what I have written here, static method. It should always start with a static method and it should have a void and it has to have a keyword called test method. Now look at the class. Inside the class, I'm starting the method with a static test method void. And then I'm mentioning the method name. Within the method name, we will be writing the logic. We will be writing the logic. Now this is the step 2. This is the step 2. Step 1 is whatever the @is test, the main class name. Step 2 is within that we will be creating the method. Method should be always starts with a static and you need to use a keyword called test method and it has to be void, no return type, then the method name. Step 3 is, the final step is invoke the test class or run the test class. Invoking the test class is multiple ways we can do it. Multiple ways you can do it. Either you can open the test class and you can click on run test button. That means when you see here, so this is the Apex class. This is the Apex class. In the Apex class, you have these buttons. You have these buttons. Developer console, new, right? Run all test classes, schedule Apex. These are there. But when you go to the Apex test classes, now if you open any test class, so here you will see a button called run test. You will see a button called run test. And the second way of running the test classes is you can go to the develop, which is nothing but a Apex test execution. Just search the Apex test execution link. Click on that. You will see a checkbox and select the checkboxes. Click on a run test button. Now here Apex test execution. Apex test execution. Now here you have a checkbox called, here it is a checkbox. Now you need to click on select a test and what are the test classes are there, you can select it and click on a run button. Click on run button. Now here you are not able to see the test classes because we have not implemented anything. We have not implemented anything. And another way is you can directly go to the Apex class link and run all test. So here in the Apex classes, you will see run all test button. One button will be there, run all test. So you will be able to see the run all test. And the last one is in the developer console. So far we have seen the UI in the developer console. In case if you want to run the test classes, create a test class. That means you need to write the code in the test classes. Once the code is implemented, once you save the code, there is something called run test button gets enabled. Now, right now in the developer console, whenever you open up any Apex class, let's say that I'm opening up the lead handler. Now here you cannot see anything. Here it says go to code coverage is there, right? Code coverage is there. But whenever you implement a test class, here you will see another button which is called as a run test. You will see another button which is called as a run test. Now, let's go ahead and implement one use case. Now, we'll take a simple use case, create a Apex class to perform the mathematical operation and prepare the test classes to test the business logic. That means I'll be writing the new Apex class. That Apex class is basically it is a mathematical operation. It is mathematical operation. That means plus, minus, what are the operations are there, everything. And once I implement the main class, that means business logic, then I'll be writing the test class here. Now let's go to the developer console. Now let's go ahead and implement the business logic first. So I'll use the Apex class here. I'll say that math operation utility, operations utility, click on done. Now this is the main business logic. Now I need to implement this business logic, public, static, void. Let's say I'm saying here method name is addition. Now I'll be passing the three values here, integer, let's say x, and integer y, and integer z. Now within this, I'll say that system.debug addition result. Now, for this, what I'll do is I'll click on a plus button and I'll say that I'm going to use addition is x plus y plus z. And this is my one method. This is one method. And similarly, I'll implement few other method. Let's say that other one is a multiply. And here I'm going to multiply the, let's take only two values. I'm going to multiply the x multiplied by y. And here this is a why it is giving error. Multiply.
The comma, integer x comma y comma in multiply method.
Okay.
Parameters.
So result is now here it is a comma and this integer spelling is wrong. Okay, similarly, I'll create another method. Let's say this is the division. And I'll use here x by y. And this is the division. And I'll use another method, which is called as a, let's say final one, modules. I'll take a two values. Basically, this is a reminder value. Now here I'll take the calculation math.mod x comma y. Now this is my class. This is the class. Now how many lines of code is actually there? One line, second, third, fourth, right? So we have a 4 lines of code. Now go to this math operation. How many lines of code? 4 lines of code. 4 lines of code it is there. Now for this, I'm going to implement a test class. In order to create a test class, I'll be using the Apex class. There is no separate name in the file. It does not have a Apex test class. It is just a Apex class. So select this Apex class. What you need to do is you need to copy the actual business logic, file, new Apex class, business logic. Then you have to use the test. You need to use the test. At the end, I have used the test. Now it shows here go to and code coverage. It is a normal Apex class. Now, as soon as I add here @is_test, that means this gets converted to the test class, and now new button is enabled here. New button is enabled, which is nothing but run test, which is implemented. The run test is enabled. Now within this, I need to implement a test method. In order to write the test method, I need to start with a keyword called static test method and void. And I need to use the, let's say that it is a test math operation. After void, you can give any method name. Now here within the method, we are going to invoke the business logic. We are going to invoke the business logic. Now how to invoke the business logic? In order to invoke the business logic, you need to copy this class name. And then what is needed here? Addition. So for the addition, we need to pass the data. So let's say here I'm passing the data X is 100 and this is some number here, Y, and then Z value. So this is the number which I'm passing it. Similarly, I need to call 4 other methods, right? I need to call the addition is done. Next one is a division. For the division, let's say that I am calling the, for X, I am passing the 20,000 and Y 400. Similarly, I'm calling the another one, which is called as a division is already done. Multiply. So multiply I'll be doing it like a, let's give it as a 4,500. And here I'll be giving the 20. And this is a module, so it's not a multiply. Let's use the multiply. Okay, so multiply, I'm passing this. And after that, we have a one more, which is called as a addition is done, division is done. Next one is a modules. There are 4 methods. For the modules, I'll just say that 406. Now, these are the test classes. This is the test class. Now everything is perfect here. Everything is perfect. We have written the business logic and this is the test class. Now let's go ahead and see in the Apex class. Now the class which I have written is mathematical operation. Let's click on M. Now, right now, if I open the math operation utility, now here it says that code coverage is 0%. Code coverage is 0%. Now, if I go to the Apex test classes, where I can see the Apex test classes, let's open this. Let's go back to the Apex class. Now here itself, I can see the test classes. For the test classes, there won't be any security here. There won't be any security. Now it just shows the edit and delete. So test classes and Apex classes, both are in the Apex classes. Now, whenever you open the test class, here is the button, you will see test classes. If it is a normal class, you will not see the run test. Instead of that, security will be there. So security and run test. If it is a test class, it is security will be replaced with the run test. And if it is a Apex class, it will display as a security. So these are the button which you will see. Now, if you click on here, run test, or else you can click on the developer console. In the developer console, we have something called run test. When you click on a run test, there is in the test, it is going to show you that green means everything is executed successfully. Everything is executed successfully. If it is a cross mark, now instead of a right mark, if it is showing as a cross mark, that means here it is showing a cross mark. That means there is a problem with the test class. There is a problem with the test class. Now, it says that everything perfectly processed. Now, if you go to that particular one, it says 100% code coverage. 100% code coverage. Now, let me refresh the Apex class. This is the Apex class. Before it was a 0%. Now it will show the code coverage is 100%. It shows core coverage is 100%. All the 4 lines are covered. All the 4 lines are covered. Now, if you go here, just double click on this math utility. What is happening? It is highlighted here. with the blue line. That means it is covering all these lines. It is covering all these lines. So system.debug, it does not look into that. It is basically debugging purpose. So it will not take that. So it has these executions are there. Now here also you can see. Now in case, let's assume that you have not written the logic for addition. In the test classes, you have not written the test code for addition. You have not written the test code for addition. That means for addition, you have not written. Now go ahead and execute the run test. When you execute the run test, it will show you that around 75. Yeah, it is showing the 75%. Just double click on this. Now what is happening? Whichever it is covered, it will show in the blue color. Whichever is not covered, or it is not covered, or we have not written the logic, it will show in the red color. Now you can click on this. Now here also you can click on code coverage. If you just click on it, it will show you the how many lines it is covered by the test classes, how many lines it did not cover. Wherever it is a red color, that means it is not covered by the test class. Wherever it is a blue line, it is covered by the test class. It is covered by the test class. Now, right now, if you refresh the Apex class, it will show here 75%. It will show here 75% instead of 100%. It shows 75%. Now here it is showing the 75%. Now let's uncomment that piece. Now click on a save. Now you can execute a run test here, or you can execute a on particular test class. You can click on a run test, or else go to the Apex test execution. Go to the Apex test execution. When you click on a Apex test execution, here click on the select test. Select test. Now here you have a one which is available, math operation test. Click on a test. When you click on a test, it will run at the back end. It will run at the back end. Now it tick means, green mark means that is executed perfectly fine. Now if you want to view the test class, you can view the test class by clicking on the view button. By clicking on the view button, you can view the test class. So in the Apex test, it is going to show you that what is the class that you have executed, what is the result. Now, if you go back to the Apex classes, now here click on the estimate your organization. Now still it is saying that 0%. Still it is saying that 0%. I'll come to this point later. The reason for why it is saying here 0, you have some more than 10 classes are there. More than 10 Apex classes are there. If it is a more than 10 Apex classes, out of them you have just written a test class for one of them, right? It will not cover. This is overall code coverage. This is taking overall code coverage. It's not taking the single coverage. Now, if you got a marks in one subject, you got 100 marks. In other subject, you got a 0, 0, 0, 0, 0. That means your overall score will be somewhere 0%. It won't be 10% or it won't be 100%. It will be 0%. Right? So same way here also in the Salesforce, it is applying the 0%. Now here also you can see that Apex classes. Now let's go ahead and see another use case. So another use case is, let's say that write an Apex class to prepare a collection of functions to be used to perform the mathematical operation. This is another class, which is a mathematical operation, where it is also we are using the some plus button or some kind of a mathematical operation or a string comparison, concatenation, whatever we have, we will implement a Apex class. For that, we will write a test class. Now let's go ahead and implement for this. But before moving on, any questions on this particular one, test classes? We will be writing few more use cases. This is a very basic one. We have not covered everything right now. It is a very basic one. So we will go step by step. So far, any questions on this? Okay, so let's move on, implement the second use case. Write an Apex class to prepare collection of functions to be used to perform the mathematical operations and string operations. And then we have to write the test classes to cover the business logic. Now let's go ahead and implement. Let's click on an Apex class. Now this is a common, let's say this is a common utility handler. So for common utility handler, what I'll do is I'll implement few methods here, public. Let's say that I'm going to use public static void. Then I'll add a addition. Let's take here integer x and integer y. Right, so I'll be returning some value here. So in that case, here, let's say instead of a void, I'll take an integer. So that means I'm returning something. So let's return, I'm returning the x plus y. Instead of a debug, I'm just returning it. Now the next one is I'm going to implement it for multiply. Multiply, for the multiply, let's take another value here, integer z, x multiplication of y multiplication of z. Now similarly, I'll take another one, which is a equal to value. Let's check the equal to, check equal. Now for this, instead of an integer, I'll be expecting the parameter, which is a string S1, string S2, string S2. And now I'm going to check the string. If the first string is similar to the second string, if first string is similar to the, that means both are matching, then it will return true. Or else I'll return false. Return false. And also I'll check the equal to case. Let's say that. Now here I'll copy this. This is not the integer, this is a string. Now this is what we are returning. We are returning the Boolean value. So here it is a Boolean. Now next one, which I'm going to check equals with case. With case. Now I'm expecting here string S1, S2. So what I'll do is I'll return S1 is equal to S2. This is a with case sensitive, and then I'll return another one, which is called as a concatenate. Concatenate. So basically, I'm concatenating the string. Now here S1, S2, I'm getting it. So I'll return S1 plus S2. So I'm concatenating the values. What is wrong here? S1 dot equals integer, it's not an integer, it's basically Boolean. And here it is a string. Okay, so this is my Apex class. For this Apex class, if I go and see in the UI, common utility class, So common utility. What is the class that we have implemented? Common utility handler. So this is the one where we have written all the mathematical expressions. For this, right now, how many lines are there? We have a 12 lines of code. We have a 12 lines of code, and the code coverage is showing as 0%. Code coverage is showing as 0%. Now let's go ahead and implement the test class. For this, I'm copying the actual Apex name. Now here I'll say the same name and with test. At the end, I'll put the word called test. And above that, I'll add annotation at the rate is test. At the rate is test. Now here, method name, I'm using the static test method void, and you can use any name here, test common or test common utility method. Now, within this, what I'm going to do is, as similar to the previous one, this is my class name dot, we have a addition, and in the addition, I'm going to pass the value. Let's suppose 100 and 450, I'm passing it. Now, it is going to execute the logic. When I run this test class, it is going to execute this particular method. It is going to execute this particular method. But whatever is returning it, I have to check whether output of this is whatever I'm expecting it, is it the same or not? Whatever I'm expecting the output here, that means addition means 100 plus 450. That means addition is nothing but 550. I'm expecting the 550. Is my logic is also giving the 550 or not? How can I verify that? What is the output is there? Because it is returning something. Because my method is returning. Before, the method was not returning. So we have simply written here. But in this case, it is returning something. When it is returning something, there is some value which is getting output of this. Now, when it gets the output of this, I need to check whatever I'm expecting it. Is my expectation and my code logic both are working same? That means expected and actual both are same or not. How can we cross verify? We can cross verify here by using the system dot assert equals. We have a different things are there. Assert equals, assert not equals. Assert equals, assert not equals. That means there are two parameters here. In the assert equals, assert not equals, there are two parameters are there, which is the expected and actual. First one is the expected, second one is the actual. If your expected and actual both are same, if you think both are same, both should be same. If you think my expected value and whatever the code output, that is the actual output, should be same, then you have to use the assert equals. When you feel that my expected value and actual value should not be the same, then you have to use assert not equals to. Assert not equals to. So for now, I'm using the assert equals. Expected is I'm expecting the 550 is output. What is the actual? Actual should be, I can directly call the method here. This is my actual. So whatever the actual is there, this is the one and this is the expected. This is the expected. Now, this is how I can cross verify in the test class, whatever the method is returning the value, right? And whatever I'm expected, both should be same, because that is how I have implemented the logic. You need to write your own test classes. That means you need to write the positive test class, negative test class, positive test class, negative test class. For example, if it is not equal to, now I'll say that system dot assert not equals to, assert dot not equals to, I'll say here 500, which is a negative scenario. It is 500 and the output should be some actual value. So these both should not be same. These values, these both values should not be same. So that is my expectation. Similarly, I'll call another method here, system dot assert equals what is my, let's say first actual I'll implement it. So actual is, I have a community utility handler. Within that we have a, let's take a multiply. In the multiply, I'll say 10 and 45, 450, and then we have a 10. Right? I'm passing these values. So what should be my expected value? My expected value will be the around 4,500. 4,500. Now this is my expected value. Similarly, system dot assert equals, what is the expected? We'll see the expected later. The actual one, let's take it. I have this community utility handler. Within this, let's go with the check equals. Now here, for example, let's say I'll say here welcome, right? And I'll give a same value here, welcome. Now both the values are same. If both the values are same, I'll get a output as a true. Now here check equals, what I'm receiving, true or a false. If both are same, I definitely receive the true. So I'll get a true here. I'll get a true, even if it is a case sensitive. In this case, even if it is a case sensitive, I'll get a true. I'll get true. But in case if I have a different value, in case I have a here welcome one, in that case, I'll receive the output as a false. So this my assumption, whenever we are writing the test classes, now whenever we are writing the test classes, how we have to write it? This is my start point. Now in this start point, what is the parameters are expected? Now if I provide some one value or two values which I'm providing it, my output should be a positive output. If I'm going a different output, if I'm providing different output, then my output should be negative output or a false output. So like this, you need to implement a structure and you need to build positive scenario, negative scenario, both in the test classes. Whenever you are writing, you have to implement the positive scenario and the negative scenario together. You have to implement both the scenarios together. Now system dot assert equals, let's say this is my class name, and what is pending here, with case. Let's take a with case. Now we have a toString. Now what I'll do is I'll pass the same data here. Now I'll pass same value, welcome. I'm going to pass it here. I'll get a output as true. But in case, this is a case sensitive, in case, if I say here, in case if I say small w, I'll get an output as false. Now let's go ahead and check equals with case. Now I'm checking here, is S1 equal to S2, which is a case sensitive. It is checking the case sensitive. Now if it is the same, that means even small letters, capital letters also it is different. If it is a capital and small, that means I'll get an output as a false. Now next one is a system dot assert equals. Now my actual is, I have a, this is the class. We have left with one method which is called as a concatenate. Now here what I'll receive is, I need to pass the toString. Let's say hello. Now comma, I'll say here test class, right? Now this is how I'll pass the data. Now let me close this. Now what is the expected here? I'll receive the output as hello space test space class. I'll receive the output like this. Click on it, save. Now this is my test class. This is my test class. Now here we are calling the each method. I'm calling it each method within the Apex class. Each method within the Apex class, I'm calling it. And also I'm cross-verifying it. What is the output of those methods? Because my logic in the Apex class is every method is returning some value. Every method is returning some value. So we need to cross-verify when it returns. Is the return value and my expected value both are same or not? Now let's go ahead and run this. Either you can run it from here. When you run it, you can see the output here. Click on run. Now this is the incorrect. That means there is something wrong. There is something wrong. Now what is wrong here? So usually whenever your test class is fails, this test class is failed. How you will know? By checking the cross button. You have a cross button here. Why it is failed the test class? You have to see here. Now, when you click on this plus button, you can see here. Just double click on this test community method. So it says that 17th line, whatever you have written, it is incorrect. 17th line, whatever it is written, it is incorrect. Stack trace is going to give you the line number. Error is going to give you the error details. What is the incorrect? The actual output is hello. Actual is hello test class. But you have here two spaces in between that. You have a expected is, I have given a two spaces. Expected is, I have given two spaces. Whereas expected is, actual is only one space. Actual is one space. Here, expected is, I have given a two spaces. If I remove one space and click on a save, and right now, if I execute it, it will give me the right mark. So this is how you will see in the real time. If any line is failed in the test class, you will see the cross button. You will see the cross button. Now, if you look at the community utility handler, all 12 lines are covered. Just double click on this. Now you can see this. These are the lines which are covered. These are the lines which are covered. Now you click on this also, right? So click on this. It is going to give you. That means all the blue lines means everything is covered by the test classes. Everything is covered by the test classes. Any questions on this system assert equals to or system assert not equals?
So we need to check for the right condition and also for the wrong condition.
Yeah.
For every method.
Yes, that is the actual behavior of the test class.
Okay, like in real time, like we need to do that, right?
Yeah, in real time, you need to do. For every method, it has to have a positive scenario, negative scenario. If you do not have any, in rare scenarios, like for integration, you might not have a negative scenario. Whenever you do not have a negative scenario, you can ignore it. But wherever it is possible, you can implement you have to implement the negative scenario. Now, homework. Create an Apex class for a simple interest calculation and prepare the test classes to test the business logic. Second one, write the Apex class to check the value is even or a odd. That means whenever you pass a value to the method, now you need to check whether the value that is passed, whether it is a even value or a odd value. So the Apex class has to give even or odd. So for that, implement the Apex class and write the test class to test the business logic. And that's all for today. I'll ping you this trial head link.